When you build a fire during a camping trip, you pile up cut logs and some kindling and set flame to it. As the fire continues, the logs burn until you are eventually left with a small amount of ash and charred remains. What happened to your original logs? Did they just disappear? According to the law of conservation, the magnitude of properties within a chemical system, such as mass, energy, or charge, remain unchanged during a chemical reaction. These properties may be exchanged between components of the system. However, the total amount in the system does not increase or decrease. In our fire example, the burning wood is a chemical reaction. Wood is made up mainly of carbon, hydrogen, and oxygen. When you burn wood, the heat from the fire breaks down the bonds between the elements. Hydrogen and oxygen are released into the air, while the carbon is left behind. Char, the black material left behind after wood is burnt, is mostly made of carbon. Because we cannot see the gases that were released during the burning process, the mass of the end products appears smaller. But if we were able to measure the mass of the released carbon and oxygen plus the mass of the remaining char, we would find that the mass of all of these end products would be the same as our original wood. The form of the matter may be different, having transformed from solid wood to volatile gases and char, but the total mass of the end products are the same as what we started with. The law of the conservation of mass was first realized by Antoine Lavoisier in the late 18th century. During this time, chemists of the day had noted that when metals were heated in open air, they were transformed into metal oxides and appeared to gain more mass. This process is similar to the formation of rust on iron when it is exposed to air and water. Lavoisier was the first to systematically measure a quantity of phosphorus, the mass of air involved in the reaction, and the resulting phosphoric acid. He found that the total mass in the system was the same before and after the reaction. His experiments allowed him to theorize that although matter may change, the total mass of the matter involved never changes. Antoine Lavoisier is considered by many to be the father of modern chemistry, due in part to his discovery of the law of conservation of mass. Antoine Lavoisier developed unique equipment that allowed him to measure the exact quantity of air combusted during his experiments. He would heat the metal on the left side of the apparatus, which would react with the fixed quantity of air in the system. The law of conservation of mass is a useful principle because it allows us to balance the mass budget of reactions, much like we balance the charge of chemical reactions. For instance, if we combine a salt solution, NaCl, and a silver nitrate solution, AgNO3, in a beaker, this reaction produces silver chloride, AgCl, and sodium nitrate, NaNO3. If the measured combined beginning mass of NaCl and AgNO3 was 20 grams, the resulting AgCl and NaNO3 should also be 20 grams. According to the law of conservation, the magnitude of properties within a chemical system, such as mass, energy, or charge, remain unchanged during a chemical reaction. These properties may be exchanged between components of the system. However, the total amount in the system does not increase or decrease. The law of the conservation of mass was first realized by Antoine Lavoisier in the late 18th century. It states that the total mass in the system is the same before and after the reaction. Lavoisier's experiments allowed him to theorize that although matter may change, the total mass of the matter involved never changes.